My PV solar water heater project requires a 12 to 15 volt power source to make it work, and you can use that with a voltage dropping resistor and a Zener, but that can get a little complicated. This is one of my favorite power supplies. You can get these from China for about $1.50 shipped. Might be a little bit more now with the postal changes and taxes and everything, but it's a cute little power supply. Comes in a metal case. It's basically your simple wall wart. You got a switch mode chip here, your isolating transformer, rectifiers, and this can be adjusted up to 13.1 volts. It's an S15W-12. It's a 12 volt, 1 1/4 amp supply, and I really like these things. The problem is that they don't work too well on just 50 volts. They used to, but then they changed their chip or something. But I have a little mod you can do to this. It's fairly simple. Now, as it is, we can pop up the voltage to 75 volts DC, and if you look over here, this little LED is flashing. This little resistor supplies current to the chip initially to power it up. Once it starts to oscillate, the power supply will be sending voltage back to run the chip. And as you can see right now, it's trying to boot up. It does, but there isn't enough sustaining. What we need to do is change the value of that resistor. Now this ties in with one screw. It's easy to slip out, and if you look underneath, this is where that resistor is. It goes from here to this pin of the chip. So let's start out with a 620K resistor. So we can boot up the power supply again, and we can see that once we get up to about about 70 volts, 75 volts, it'll start to work, and this is supplying 48 milliamps. Now my board normally takes about 10 milliamps, so that's way extra, enough for running a few other devices, and just a little extra safety margin. But that's not good enough. Let's go and put another 620K resistor in there. So that's about 300K. Once again, we take the power supply up, and once we get to about 58 volts, it runs. So that's 58's not too bad if you have a string of 2 grid tie panels. That'll give you easily 60 volts. Now once it starts running, it'll stay running till you get down to about 30 volts. So once you power it, it'll keep going even if you have fluctuations of solar. But still, that's a little high for us. The resistor I suggest is 100K. As you can see, you can just lay it right in here, solder it, and it'll fit easily back in the case. So let's try it again this time. And at 47 volts it comes on. So that would work for a 36 volt string or even higher voltage. Now once we go down, it's still going to be about that 30 volts where it shuts off. That's because it still is supplying power once it runs from the output of the transformer. So this is with the 100K, and we have a 48 milliamp load on it. If we take that 48 milliamp load off and make it 23 milliamps, you can see that it'll start at a much lower voltage. So that's like 41 volts. And again, we can go down to about 22 volts. So that's a pretty good range. It's a $1.50 solution, and I've shown this before. You can take out the diodes because you'll have a 1.2 volt drop with that, but you know, then it requires you being aware of having the polarity correct. So I suggest you just leave it like this. Just get a 100K resistor and bridge it underneath, and then you have a nice supply. Here's the voltage pot. Crank it all the way clockwise, and that gives you around a little over 13 volts. So in reviewing this, at 23 milliamps, it'll start at like 41 volts, go down to about 23. The supply consumes about 1.7 watts at 48 milliamps. You know, you'd be dissipating that in a resistor or something else. 2 watts isn't bad. At no load, it goes down to almost a half watt. And it's just a little over a watt with a 23 milliamp load. So I highly recommend that you buy one of these instead of fooling around with some kind of power supply and try and get a Zener regulated supply working over a wide voltage. Thanks for watching.